Okay, we're at time, so why don't we kick off? Good morning. Welcome to the OpenPGP session. My name is Stephen Farrell. My co-chair DKG is the giant screen at the back at the front of the room. So
Hello.
so I have the clicker, so I'll click. We have a note well. Essentially, when you're participating in the IETF, you agree to follow various processes and behave well and so on. And you should familiarize yourself with those if you haven't already.
Note that this is the new note well.
Is this the new note well?
It is. It is. We're on
This is the
top of
new
our
note well.
game
So,
here.
as you'll very quickly tell, DKG did all the work preparing the meeting. So this is the new note well, not very newly well. Again, we have a whole bunch of remote people today. So for in-person participants, please sign in to the meeting via MeetEcho. If you're going to use the mic line, it'd be nice to join us. If you're remote, please again make sure your audio and video are off while you're not presenting or in the queue and talking. The rest is there. So here's our agenda for today. We're going to do a little bit follow up on the interim, some status on existing working group documents, and then we had quite a while back, I can't remember exactly how far back it was, a couple of years maybe, we did a big triage of a list of things people wanted to do and see who wanted to do what, and we've kind of chunked through a bunch of those items, so it's probably time to repeat some parts of that exercise to see who wants to do what, or we could just close down if everything's done. So that's our agenda. Any agenda bashing? Just give remote people a chance to bash the agenda. They don't seem to want to right now. Nobody in the queue.
Okay. So for the interim follow-up, we just wanted to give folks a chance to present the outcomes from the interim. And we have slides from different people. So I think the first up we'll have is Falco. Stephen, can you hand Falco the control?
Where's the slide? Which slide set is that?
They should be ordered in the.
Looks like it.
That's it.
Okay, Falco, pass slide control. You don't need to request it, Falco. I can just drop it on you. You should be in charge of the slides.
Yep, it's working. Yeah, I present the new developments regarding the NIST brain pool curves composites that we want to introduce, and we recently passed a call for adoption, and now we in the interim and on the list we had discussed the algorithm combinations, and we came down following the discussion we came down to this proposal, which actually is the one that Simo posted on the list, and we found it convincing for a number of reasons, because it's first of all meets the criterion that it's down to 8 code points. It drops the smallest parameter set, which was also kind of the preferred option, maybe not strongly preferred, but preferred option that we took away from some comments. And the only the real difference to the parameter choices in the main draft that is now in publication is that the security levels are equally paired. So if you look in the rightmost column, you would see that it's 129, 192, 192, and not this mismatch that we had intentionally in the main draft. So, but this was somehow that we took away that the people prefer, and also using the higher the larger curves, the 512 521-bit curves. And yeah, this is our proposal. We'll still call for a discussion on the list, but if there are any comments now, we could discuss them. right now. Yeah, please, Stephen.
So, not as chair, but just as somebody who hates adding loads and loads of code points for this stuff. Do we have, for example, 101 and 103 and 105 and 107? I forget if people explicitly said, I really need this, or if we're just adding them in case. Can you clarify?
I think it's a bit difficult to say we need specifically this one, but the number that we heard in the last meeting, in the interim meeting, was that we should get down to 8 code points. So there was no other indication from the working group. I mean, we could, if we ask this question, we could come up with a, maybe no one has a specific preferred parameter set, but we need to define some. So it's up to the working group to have an opinion about this set, but I don't think it will get us forward to really identify one that is needed or not needed, because I don't think that we didn't hear these strong requirements. So we think this is a reasonable option to have 2 parameter sets, the intermediate and the high security levels, somehow similar, or at least regarding the PQ components, it's oriented towards the main draft. So this is the philosophy that I see here. If there's an idea to divert from this, then I think we need concrete proposals.
Hi, Sophie Schmeek, Google. Do you know of anyone who uses P521? Because I don't. It's very, very slow curve. Also, it would be great if we could swap it out for X-Wing. That would be amazing, because that is like kind of the thing that everybody else is using. So having at least the one thing that everybody else is using also in PGP would be really nice.
So just to clarify, there's other code points in the main.
Oh, that I might have missed. I was too late. So
not X-Wing, but
yeah. In that case, for the other code points, it would be nice to have X-Wing, because that is like supported in a lot of libraries already. Adding it to PGP makes that a lot easier. Not gonna say that this is impossible to add, but it would be nice to have like the one scheme that we all collectively dislike the least.
I think Tempest as fugitive on that document is gone further. So Stavros? Or sorry, Falco, do you want to answer?
I just wanted to say this draft is about adding NIST and brainpool curve parameter sets.
Stavros?
Yeah, hi everybody. One answer to Sophie's question. So X-Wing basically up to the label is in the baseline. So it's in the base PQC draft. This is just an extension of code points. Okay, so the question was if we can just strike out some combinations. So I can only speak for the BSI use case. So let's talk about 102 and 103, because the same applies to 106 and 107. This is a level 3 and level 5 security sets. We have both recommended in our technical guidelines, so this kind of matches this. And I've seen people using, currently we have OpenPGP with brainpool curves, and I've seen people using brainpool P384 and 512. So this kind of matches what is used at the moment, and matches also our recommendation, the technical guidelines. This is what I can say from the BSI point of view. The reason why we paired this in the past, so MLChem 768, not with the 384-bit curve, but with the 256-bit curve. And likewise, we didn't have the 512-bit curve, but the 384-bit curve with MLChem 1024, is that I rarely have seen 512-bit curves in the wild, and I thought it's a little bit easier. Yeah, but this is what came back to us on the mailing list, and well, I don't know. And if we strike out one of those code points, I don't think it would make things a lot easier. It would be one less code point, one less test vector, but it will not really reflect in smaller code size because these are randomized curves. You will have one implementation handling both. So I don't know. Whatever. That's from
Yeah.
my point at least.
Sophie Schmick again. So up to the label means you don't have it, unfortunately, because these things, when you change a single bit, are not compatible anymore. I think the main reason that we don't see P521 or even other 512 curves in the wild all that much is because elliptic curves scale cubically. ML Chem scales quadratically, so it's much, much more palatable to have ML Chem 1024 than having 512 anything. That isn't necessarily the most sound security discussion on bit sizes, but the flip side of that is that it's questionable whether there is such a thing as a sound discussion on bit sizes at all, given that a scheme is either broken or not broken, and most people don't really care of whether it's broken at the end of the universe or at the end of the solar system. So I usually think of it more as like how much room we have and how much we can afford, and from that perspective, you can be more conservative on the ML Chem side just because it's much cheaper to scale up ML Chem than it is to scale up the curve. That is my main reasoning. You can get into philosophical arguments what a bit size in security actually is, but
So I just wanted to check in. We are tight on time. We have a 2-hour slot, and we have a bunch of different discussions. So yeah, let's move along.
Yeah, we move on to the next slide, which brings us to the signature context parameter. So we had also discussed this in the interim. We didn't see any strong vote for using the context parameter. We came to the conclusion that it's more appropriate to align it to the base draft, and also we have the, let's say, if we used it, we had the inconsistency that ECDSA could not be taken to use the context parameter. So we could only use it for the PQC variant, and we don't see it as the pro arguments, the gain in security against cross-protocol attacks. We don't see this sufficiently strong argument to change the implementation and run into the risk of having incompliant crypto libraries that are not able to offer the context parameter. Okay. Then our plan is to make the new version with these changes, also including test vectors, and post it on the list and wait for comments. Okay.
Thank you, Falco.
So just Falco, do you think it's the author's opinion that that new version would be ready for working group last call?
Yeah, if it's not criticized in the working group, if it's accepted, if we get consensus, then yes.
Okay, so the plan would be you guys will update and post a new draft. We let it sit and see if anybody explodes, and if nobody explodes, we can think about a working group last call.
Yes.
Great, thank you. No other comments on that? Good.
So next up is Andrew to talk about key replacement. Just to follow up on what happened at the interim.
Hello.
Andrew, I'm giving you slide control. I guess.
Thank you. Is my audio okay? Sorry, I didn't
Audio's
arrive.
good.
Sound check. Okay, thanks. Thanks very much. So this is following up from the interim meeting, and I really don't have anything more to say than I already said at the interim meeting, so I will keep this very, very short, hopefully. So this is just a recap of the basic design. I just threw this up for context for anybody who isn't already familiar with it. The idea is there is a new signature subpacket. It goes into self-signatures and revocation signatures to provide a hint for where a newer certificate can be found. And if there are, and it works in both a forwards and a reverse mode. And if there is a matching forward on one certificate and reverse on the other certificate that point to each other, then we have what's called an identity equivalence. And the idea behind identity equivalence is that if you trust one of the certificates as the correspondent, you should trust the other certificate. And this provides an easy, relatively transparent upgrade pathway, so long as everybody has the latest copy of everything. But that is a generic problem in OpenPGP that we're not going to address here. So the current status is that the wire format does appear to be stable. We have no open questions about changing any of the fields or any of lengths. Last change was to pare down a 2-octet length parameter to 1 octet, as 2 octets was excessive. Aside from that, there have been no recent wire format changes. The draft text itself is stable. There has been some feedback on the list indicating that people believe it is mature, and there are numerous worked examples in it. We could always add more if people think the current ones are inadequate, but there has been no specific suggestion as yet. One thing that it doesn't have that the other drafts in a similar state of maturity do have is test vectors, but that feeds into my next slide. And the next slide is basically we don't currently have any interop testing for this draft. So I will repeat my request to all the implementers. If you are interested in this mechanism, if you want to implement this mechanism, please stick your hand up, say, I would like to implement this. And the people who are willing to push forward with implementations can work on the test vectors and the interop testing. Because the current interop test suite depends quite heavily on SOP, I think it's generally agreed that SOP needs to expose a mechanism or an interface for higher level code to produce and consume these artifacts. So there are some open merge requests and issues in the SOP repository, and I would encourage everybody to go over there, please, and read those, specifically the 3 that are linked on this slide. And if you have any opinions on those particular suggestions, please raise them there and or on the list. So we're in a strange situation where progress on this draft is actually blocked on progress on another draft that is not even adopted, but we are where we are. I would strongly suggest that we do adopt the SOP draft, but that's a discussion for later in this meeting. So that's my quick recap. Basically, nothing more to say since the interim, but if you have any questions, please let me know.
Okay, don't see anybody in the queue.
Okay.
Great.
Thanks.
Thank you.
So next is feedback from Daniel Howens about the persistent symmetric keys draft from the interim.
Yes, thank you. Yeah, so for those new to this working group, this is about adding the use of persistence metric keys to OpenPGP. In the interim, we talked about a few different options about how to encode and store persistence metric keys and other artifacts. And I would say there was no sort of single outcome. You know, different people have different ideas and thoughts about how it should be encoded and stored. So yeah, I spent some time thinking about the different options and ended up picking one with kind of an added twist, because I started thinking whether we really need both AAD and HMAC, and came to the conclusion that maybe we don't, because we could simply use an AAD construction as a MAC by encrypting an empty message and passing the thing that we want to authenticate as the additional data to AAD, and store the IV and the resulting authentication tag in the place where the MAC would go. And this is actually something that seems to be approved by NIST as well, and seems to be solid. So that allows us to kind of simplify the proposal and reduce the number of primitives that we're adding to OpenPGP, which is kind of nice. And also allows us to more cleanly allocate the special public key algorithm ID 0 to mean no asymmetric encryption, just symmetric encryption, and meaning always AAD. And we retain kind of the AAD algorithm registry as a point for future expansion, but probably most likely don't really need to add more other public key algorithms in the future at that point. And we also don't really need to rename any packets or registries in that option, in my opinion, since it's kind of clear that if we use algorithm ID 0, that it's not a real asymmetric algorithm. So yeah, that's what the new draft says. So we have one algorithm. Yeah, no, this was not discussed at the interim. This happened afterwards. But yes, new draft suggests one algorithm ID for AAD, which can be used both for persistent symmetric signatures and persistent symmetrically encrypted session keys. And as before, there is a packet. This was discussed in the interim. Persistent symmetric key packet to store a persistent symmetric key. And that way you could also store only a single persistent symmetric key packet if you wanted, and use it in theory even for both persistent symmetric encryption and signatures, though we have to double check sort of domain separation and cross use case attacks. But since there's the additional data parameter, we can maybe hard code some value there. So yeah, should be solid. So yeah, questions is, can everybody live with this? I know we've gone kind of through a few different iterations, and there's kind of a lot of different options and bike shedding possibilities. But I would kind of like to, at some point land on an option and go with it if we can manage. But let's see if there's any comments on this iteration. So yeah, I minted the new version of the draft. Can read it there. Let me know if it seems reasonable. This version of the draft doesn't have test vectors for now, unlike the previous one, since didn't have time for that. If this change seems reasonable, then I'll add test vectors and mint another version of the draft. So yeah, that's about it from me.
Thank you, Daniel. Any other members of the working group want to comment or ask questions? We can move on. If not, thanks, Daniel. Stephen, can you put the chair slides back up? Or I can do that. Here, I'll do it.
Okay. Yeah. So just on the last point, Daniel, my understanding is that it wasn't an item discussed at the interim, and it's a relatively new idea. So we shouldn't be surprised if people take a little while to come back and decide they like it or dislike it, right?
Yes, makes sense.
Okay.
So thanks. That covers the drafts that we have that are currently outstanding. There's also the OpenPGP PQC draft, which had a little bit of follow-up on the list in terms of sort of final stages review. I hope folks on the list will read that and give feedback. What we wanted to focus this meeting on is next steps for the working group. So just as a framing point, I want to point out that we have our charter listed a bunch of different things as possible work. These are the specific subpoints that were listed there. And as you can see, we've managed to sort through 3 that are bolded here, which is good. And we have a big chunk of other things to do, potentially. The ones that are in italics with a little asterisk afterwards are ones that we have potential presentations about today. If folks bring up other potential work items, we can talk about those too. But we want to think about what sort of things might be interesting for adoption, what would be useful. So Andrew Gallagher is the, guilty party behind a bunch of this work. So Andrew, we're going to call you back to, we're going to bring back the HKP discussion here. But if folks want to think through these and propose work items, that would be useful. Andrew, I see you coming up. I'm going to switch the slides over to your HKP slides.
Just before we switch over, I just point out that message grammar is also addressed in the same draft as semantics, or at least in the current version of it.
Ah, great. Sorry, yeah, I had missed that, and that's my mistake on the slide.
No, it's perfectly fine. It doesn't really call it out in the title or the abstract, but it actually does. That's one thing that I'll come to that later anyway.
Great. So Andrew, you wanted to talk about the HKP draft. You can go ahead. There's your slides. I'm going to try to give you control.
Yep. Thanks very much. So while Daniel's fiddling with that, we've had a considerable amount of discussion about this draft. Thanks, I have control. We've had discussion about this draft in the keys.openpgp.org board over the last 9 months, I suppose, and getting a common agreement between keys.openpgp.org and HockeyPuck on a way forward with this draft was one of my priorities and was one of the reasons why I volunteered to join the KO board for this year, because I think it is very important that we have a common API for key servers. So the brief for this redesign of HKP is that we really should have an API that can be used for all purposes or all reasonable purposes. Currently, we have the traditional HKP legacy, as we call it in the draft, which has been going for 25 years-ish. And it's showing the age. It has some issues, and there are some assumptions baked into it. More recently, we have WKD and the VKS API, which is currently implemented in keys.openpgp.org, and those do slightly different things and also have assumptions baked into them as well. And so what I think would be best for the ecosystem moving forward is having a unified API, which would have features that some key servers could expose and other key servers might not wish to implement, and that should be fair enough. So the idea is that we would be able to provide a minimal service over this API. Clients would be able to detect if other services were available on it. We've specified the use of the options verb in HTTP for that. It should also be able to act as a database for a key discovery mechanism like WKD. And also we should be able to submit certificate material to a key server by more than one method. And the main reason why I think this is important is because we have an evolving idea of anti-spam measures, email-based proofs, signature-based proofs, and so on, which we shouldn't bake into our API itself. We should allow these to evolve over time without placing restrictions or unnecessarily in the actual format of the API. So the current design is that we have a RESTful API for our modern V2 style endpoint. We specify a pre-auth email verification, which I'm calling prove then submit. This inserts the current proof method used in keys.openpgp.org, which currently uses submit then prove. And this has some issues with, when you submit a key, you should get an email response, but sometimes you might get one. Sometimes you might need to request a proof. What happens if somebody else submits it on your behalf, and so on? We believe that prove first then submit is a more reasonable method. We specify a method for key discovery, WKD style, but using SRV records. This is an old idea that has come and gone a few times, but I think most people are agreed that SRV is the best balance of cost benefit for this. We define the concept of a canonical certificate bundle, which again is like what you would get from WKD, which these are my certificates, plural, which may include a V4 and a V6. These could contain the key replacement mechanism that I spoke about earlier to tie them together cryptographically. So this is like WKD, but with the extra functionality or the extra elbow room required to allow clients to handle multiple versions and handle a much more graceful upgrade pathway. We're deprecating ASCII armor in the HKP API. The new API will use binary because it's just a better idea for APIs. And also we expand the idea of JSON status responses. HockeyPuck currently sort of does this in practice, but we're going to formalize this in this draft. And as I mentioned before, we have a legacy HKP API, which has been sitting in draft form for 20 years, and which was the basis for this draft, which has evolved over time from Daphne's original specification. But you will still see a large amount of that in the current draft. So over the last couple of months in KOO board, we have basically pulled apart the V2 API and put it back together again. Daniel Hagens has been particularly helpful with this and has done a lot of work in designing the structure of this API. The idea is that we have a basic certificate lookup, which is similar but subtly changed from the legacy HKP API that people may be familiar with. There's also a canonical route which does the job of WKD. And then we also have a prefix log endpoint, which allows a client to request the prefixes which the key server can tune of all of the certificates updated on a particular day. And the idea behind this is that this would allow clients to pool for updates without revealing the contents of their entire key ring to a key server, which may then record excessive amounts of private information. And on the submission side, we have 3 endpoints. We have a traditional style submission process, which again mostly mimics the legacy API. Then we have a canonical bundle submission process, which is like an HTTP version of UPG's WKS server implementation, where individual people can submit their own certificate bundles and say, this is my canonical bundle that I want everybody to get if they do key discovery for my email address. This is all HTTP based. There's no email based submission like a WKS server, but we do have this send token endpoint, which allows the server, which requests that the server should send a time limited one-time verification token to an email address, and that can then be submitted as part of the submission as a proof or as evidence, let's say, to prevent spamming mainly. So there are a couple of outstanding ideas that were in the draft, such as the format of the email proof ID, the token ID. One idea is that this token should be machine readable, this email that contains the token should be machine readable, and this should use JSON LD because that is the emerging standard for machine readable emails. That specification has not yet been nailed down, but I think that this is a good way forward. There's also the suggestion that we could have an alternative authentication method, which would be out of band. That's still work in progress. I have a separate document in the same repository containing some thoughts about that, but they're not in the draft as such yet. And also this idea that we could have recursive lookups, which would be that an HKP key server could look up a WKD server, for example, on behalf of its clients. And this would allow an HKP server to become almost like a search engine for other forms of key store that are not necessarily HKP compatible. Those kind of extra features aside, I think the draft is currently in a state that is fit for working group adoption, and I would like to request that it be adopted. I'll send an email to the mailing list to that effect, but I think we have come to the stage now where it should be adopted. So implementation in HockeyPuck is funded by NGI Zero Core. A lot of the basic groundwork has already been done. There will be a version 2.3 of HockeyPuck out very shortly, I hope. And then the version immediately after that will be the one that supports all of this, plus RC 9580 and post-quantum encryption keys based on the PMGC OpenPGP implementation that we rely on in HockeyPuck. Similarly, in Hagrid, which runs keys.openpgp.org, the KO board has approved that we will move forward with HKP v2, and we're drawing up a plan in the board at the moment for implementation of that. So that is me. These are the appropriate links, and there's just a mention here about the discussion document that's not currently reflected in the draft, and does not necessarily need to be in this draft. It could actually be separated out into a separate document at a later date. So thanks very much. Daniel.
Thank you, Andrew. So I just your last note I think is useful, saying that we might not do the out-of-band email delivery verification.
Yeah.
This, if we're going to do that, we probably should coordinate with the SML group, which is where the structured mail is happening. If we're doing some sort of JSON LD something or other.
So there are two things here. If I can back to, I think it was it sticks. So the idea would be that the method that is specified in this particular draft, the sending a verification token by email, the suggestion is that this should be JSON LD. So the extra work, the extra document that I mentioned later, could probably might require JSON LD. That my current thinking is that it won't require JSON LD, but the current send token method that we are talking about right now in this version of the draft, I think should be JSON LD. So yes, I think in answer to your question, yes, we probably should coordinate. But I think it's relatively straightforward. JSON LD is a container essentially, and if you define your own namespace within JSON LD, yes, you can essentially do what you like.
So I just want to encourage you to reach out to the SML group to make sure that, because those are the folks who will have the better an understanding of what the current best practices are and what sort of the current tooling is that would work with that.
Sure.
So
thank you. Yeah. Okay.
So if we don't have anybody else want to speak to this, Andrew, I hear you asking for this for adoption.
Yes,
so we will raise this on the list and see what the list thinks about adopting the HKP draft. We would need some folks to, commit to reviewing and potentially implementing if we're going to adopt it. So, we will follow up on the list about it. I don't think we're going to be calling for adoption anywhere here. Right now, this is an opportunity for folks to know what kind of work is being done.
Sure. Thank you.
Thank you, Andrew. So let's see here. I'm going to take back control of the slides from you. And I'm going to switch over. I'm going to do a presentation of a brief bit of work that we can also consider for adoption. Again, I plan to ask for adoption for this. As a co-chair, it's a little bit awkward for me, but if somebody else wants to drive this, I'm also happy to let them drive it. So this is a small bit of work here that I've done that just says, look, people want to use hardware tokens for OpenPGP. We're calling them external secrets in this draft, just so that we don't get confused about whether it's actually a physical smart card or any other kind of storage. You could imagine even a software-based isolated thing, TPMs, GNUCs, all secure enclave, all these kinds of things. As long as what we're saying here is, if you're an OpenPGP implementation and you know how to access any of these, you'd like to be able to offload some of this asymmetric secret key material to them and let them handle it. So I am proposing this not because I think smart cards or hardware offload is a great idea. I actually think that there are problems with it. If you read this draft, you'll see a list of some of the concerns that I have about them. But people are trying to do it all the time. And so it seems like we should have a clear interoperable way to do that. The wire format changes required by this draft are minimal. It's a very limited change to the OpenPGP spec. And I think it makes everything kind of fall out cleanly. So this might also just be an easy win. We can just look at it. There's not much else to do and move on. So these are the changes. The changes are we take the S2K usage octet registry and we add this yellow row to it. I put a question mark next to 252 because we don't have any reserved experimental space. This is a good reminder that we want reserved and experimental space. But if you recall, this registry is sort of the evil twin of the symmetric cipher registry. So it reuses a bunch of existing octets for this legacy CFB mode. This is the table that's used to indicate how your secret key material is protected in a transferable secret key packet. In a secret key packet that's part of a transferable secret key. And the current recommendation is that you store your secret keys encrypted with AEAD mode. That's S2K usage 253. And this proposes just adding an S2K usage 252 that doesn't actually store the secret key material in the secret key packet itself. So basically, it looks like a public key packet with the exception of the packet type, and this marker that says the secret key can be found externally. But the rest of the grammar ends up being shaped exactly the same. This spec does allow for an optional external locator hint that says how you can find it if you're capable of using multiple different methods, like you know about TPMs and you know about USB sticks and you know about a smart card reader. Maybe you want to optimize how you search for it. But the expectation is that every implementation will use its best effort and look at whatever capabilities it has access to try to find the key, and it will find the key by looking at the public key material. So if you can't find a key by public key material, if you have any of these devices and you don't think you'll be able to look up the public key, to look up the secret key by public key material, then please give a shout. That's the basic expectation that this draft has. It says, given the public key material, you should be able to find the key from one of these cryptographic offload engines. And then we have this external locator hint that basically says, if you want to, you can stuff a hint about where to find it, but we expect you to do best effort anyway if the hint doesn't pan out. And none of these hints are explicitly assigned. At the moment, we're not defining any of them. We've just defined the registry so that if someone wants to come along and say, hey, here's how you store the name of the USB stick to look for, we can just allocate one and they can store it and be on their way. The weird side effect of the table being the evil twin of the symmetric cipher is that we are burning one more symmetric algorithm code point with this proposal. You can't use 252 anymore for symmetric algorithms because it would collide with this indicator. I don't think that's a big cost. And finally, I wanted to observe that there is some prior work on smart card offload. GNU-PG uses an experimental S2K specifier, which is different than S2K usage because OpenPGP is confusing. What else is new? But this fits in a different way. So note that I've got S2K specifier bolded here. If we look at the existing table, we can see that there's an S2K specifier listed in usage octets 253, 254, and 255. So each of these, currently, if you use the GNU-PG mechanism, can point to a smart card while containing a bunch of other unused information. And then, of course, the choice of which of these octets is used is unclear. And it contains a sort of, it burns a experimental code point, which we can't specifically specify. Yeah, and they also use it as a hint only. They store some locator serial number for a smart card, which they also use as a hint. So it's not that different from what we're proposing here. What we're proposing here just should be fairly simple and cleaner. So to test this, we don't need any changes to SOP. I've tried already building some secret keys that look like this, and the SOP implementations handle it okay, as though they don't know what the secret key is. There's some brittleness that needs to be fixed, but otherwise it seems to be doable. So basically, this is just add one code point to the S2K usage registry and set up a new registry for locator hints, but don't define any of them, and be done with it. So if the working group is interested in this, if we have implementers who kind of want to do it, who want to play with smart cards, this might be a useful piece of work. Any comments or feedback? I'm certainly happy to give change control over to the working group. Andrew?
Yeah, sorry. I'm absolutely nitpicking, but since the symmetric cipher algorithm registry is included in the S2K usage, does that not include the experimental range as well?
That's a good point. It's not marked that way in the registries. But as you are our resident registry janitor, apparently, that would be a good thing to consider throwing in here. Yeah, perhaps we could do that.
Completely drive by. Anyway, for another time.
I was expecting actually to drive by on this slide here, where there's a weird gap between 191 and 248, but you know, I left that in so somebody could complain at me. But you picked a different one.
Okay, so I don't see other people here. And so I guess, would it be fair to say, DKG, the state of this is if people declare that they'd be interested in implementing it, then we should have a look at it. If nobody wants to implement it, it's probably just a good idea, and that needs to wait for its time to come.
I think that's accurate. Heiko did mention this when we had discussion on the list of things that working group might want to consider to adopt. And I know that he's got some smart card work underway. So we can maybe see if he's interested in that. I don't know if other implementers are doing smart card work. Daniel, Aaron, are you guys doing smart card work that you're aware of? Aaron, I think you're speaking, but I'm not getting any audio from you. Okay, no smart card stuff from Proton's side. Fair enough.
Okay, well, I guess if you post a message to the list saying, pointing back at this bit of the agenda and saying, this is a thing that we'd be looking for implementers for if we want to then do a call for adoption. FIDO stuff, not on page. All right, next one.
So I'm going to call Andrew back to the mic here. So Andrew has a bunch of different drafts that are sort of percolating in the OpenPGP space, and he'll give us a rundown of the things he thinks are interesting here.
Okay, thanks very much. So this is a bit of a catch-all slide deck. So I'm going to cover 4 drafts here, 3 of which I think are relatively small, limited, and I think could be picked up if the working group wishes to pick them up or not. I'm not particularly wedded to being the owner of any of them. I just think that they are things that we should consider doing. If somebody else wants to pick up and run with them, I'm very, very happy. I have plenty of other things to do. And the 4th one is a bit bigger, but I'll get to that in due course. So let me start with the small stuff. So there's a draft OpenPGP media types. This fell out of the HKP work that I discussed previously. And the idea being that because we are moving the API to a binary API rather than an ASCII armored based API, I realized that the content type headers in any of the HTTP requests are technically going to be wrong if we use any of the existing media types. Because the existing media types that were defined in RFC 3156, which is the PGP MIME RFC from way back, they are all specifically and explicitly ASCII armored. So we have application PGP keys, which is an ASCII armored keyring, or what we are calling a certificate bundle in HKP these days, because keyring is an overloaded word that I'm trying to avoid using. There's application PGP signature, which again is an ASCII armored signature. It's actually this slide's wrong. It's actually not just a packet. It's probably a detached signature as per the signature grammar. I need to double check that. And there's also this weird format called application PGP encrypted, which isn't even a PGP format. It's actually the fixed string version :1, and it's used as a placeholder in the MIME structure in RFC 3156 for reasons that I don't care. It's a historical curiosity from my point of view, anyway. So 3156 predates the extension of MIME types to media types. So it's understandable that 3156 only really talks about the types that are required in a MIME email message. But these days, for HTTP-based APIs, we really should have media types defined for all of their formats. And what is not covered are messages, secret key formats, or anything in binary or non-armored format. So what this draft does is it specifies 2 new media types: application PGP secret keys and application PGP message, a natural extension of the existing types. And it also defines media type parameters, which are the bits after the semicolon. And it only defines one, which is armor equals true or armor equals false, which indicates whether the object in question has been ASCII armored or not. The default, unfortunately, is going to have to be armor equals true for backwards compatibility with the earlier definitions of the media types in PGP MIME. But the draft recommends that we use armor equals false in future APIs unless there is a specific reason that we need 7-bit clean data. Email being the obvious suspect there. And there's also a little drive-by fix which allows us to prefix detached signatures in a certificate bundle. This is what HockeyPuck already does. It is kind of what WKD already does, except WKD suffixes the detached signatures, which makes the parsing ambiguous. So I think this is a very useful fix. It's only useful for legacy stuff, v4 detached signatures, and so on. But I think it still needs to be defined for backwards compatibility. So the draft is here and the repo is here. I don't know, Daniel, do you want me to pause between these, or will I just rattle through?
I think pausing is good if folks have questions. I'd be curious if anybody with broader IETF context understands what else we would need to do for this media types kind of work. It's not really in the usual OpenPGP buckets, but it is, I think, in Charter, but we also might not have the right people in the room to make sure we're getting the media type stuff right. Stephen, do you have any thoughts on that? Or anybody else here?
Yeah, typically you got to try and go and find somebody who knows about this and then ask them, are you doing the right thing? So
I did do that, actually. I was talking to I forget the name. I was definitely talking to somebody from the media types experts a few months back, because we discussed this at the last IETF, and I did go away and this proposal seemed to be fine. I think the general reaction I got was, yeah, this seems reasonable, but it was non-committal.
Yeah, if the working group adopt work on this space, we can certainly find the right people anyway. So I guess, I mean, probably a typical question for these is who'd want to implement.
So, well, I would like to implement this in Hockey Puck, and it would be nice to be able to reference it from the HKP draft.
It's also a little bit strange for who would implement here, because most of the implementers are OpenPGP implementers and not MIME parser implementers. So
yes, this is specifically a media types registry question rather than a MIME types registry. I don't expect any of these new types to be used in a MIME context. These are very much for API contexts.
right. So what I meant was that the folks who are implementing here are often not implementing HTTP as well. And Simon has a link in the chat for further review that he's had good success on. So thank you, Simon. That's useful.
Brilliant. Okay, I think I will move on. Okay. So the second thing here is Greece. So for those who aren't familiar with the term, it is it's an RFC that came out of the TLS working group, I believe, and the idea is that several TLS cipher suites, as are referred to in TLS, several cipher suites are reserved by this RFC for interoperability testing, and the idea is that you can generate artifacts with these cipher suite identifiers, and the receiving implementations should gracefully ignore them. And this is to this essentially is to keep the parsers and the receivers working correctly, so that when new cipher suites are introduced, that we can be confident that they're not going to break existing implementations. And this is something that we've discussed quite a lot recently and by recently I mean over the last few years in OpenPGP, where if we define this new thing, is it going to break an old version of some legacy software? And we dance around this quite a lot. So while this is not a complete solution to that problem, I think it would definitely be useful in that it will help surface these errors in a controlled environment before they become critical. So this particular draft that I'm talking about reserves 8 code points. I don't think we can afford to burn any more than 8 in an OpenPGP registry, being only 1 octet. They are all of these code points are currently unallocated in any registry, and the idea would be that these would just be blanket allocated across all registries. In the vast majority of registries, this is not going to be an issue. The only registries where we have a significant amount of allocated code points are the signature subpackets and the asymmetric algorithms. But even so, that's why these numbers start at 51. These are reserved for interoperability testing use, again, across almost all registries. There are 1 or 2 where it doesn't work, but the vast majority of them can take it. And an implementation, and I'm thinking particularly perhaps a key server, can create these objects with Greece code points, and receiving implementations are supposed to gracefully ignore them. If we introduce these in a controlled manner over time, what should happen is that we should expose errors in client implementations and get them fixed before, at some point, we end up defining something that breaks backwards compatibility with all sorts of legacy code. There's a little drive-by in this one as well. It aligns the private experimental area size to 16, which covers an entire nibble that is 97 to 102. Sorry, 112. Sorry. So I know we have been struggling, particularly in PQC, with a restricted number of experimental code points. So just this tiny little bit of extra wiggle room, I think, would be really useful. So again, this is the draft, this is the repo, and if anybody has any questions, please speak up. Thank you.
So I had a question about this draft in terms of how we would know if people have implemented it or not. It seems like it's not actually asking for implementers to do anything. It's just asking IANA to designate code points that we can then use to show that implementations might be brittle and help find out where to fix them.
Pretty much, yes.
So I don't have a great way to test whether an implementation has adopted this. It really seems like it's just it's IANA cleanup more than anything.
Well, you could, can't you just ask them?
Well, what are we asking them? Will you implement this?
Do they ever emit greased packets, or will they break if they see them? You can see if they emit them.
Oh, the control space is quite large on some of these implementations. It's not. I can never be sure whether I'm going to emit these packets or not. But
Daniel?
So the interrupt test suite currently has a bunch of tests with algorithm ID 23, or also packet ID 23, and so on, which are kind of used in a way to check that unknown packets and algorithms are ignored, which is kind of what we want to test here, right? So theoretically, like the interrupt test suite could use these grease code points instead, and be sure that those algorithm IDs and those test vectors will forever refer to unallocated code points, right?
Yep.
So I think that's kind of a useful use case.
So just, so I was aware that it used packets with version number 23. I wasn't aware it used algorithm 23 anywhere. I think algorithm, certainly asymmetric algorithm 23 is allocated, it exists. But you did, yeah, the interrupt suite definitely uses version number 23 for stuff, yes. So I think the idea behind this is to extend that to all of the registries and move it into and providing the 8 code points rather than just the 1 also discourages people from treating the test code point specially, because if everybody knows that 23 is the test one, then it's very easy to just add an entry 23 is the test one into your internal implementation, handle it specially, and that completes the entire purpose. So the way that TLS grease works is, now correct me if I'm wrong, but I think it runs along the lines of the code points are like 1F, 1F, 2F, 2F, 3F, 3F, 4F, 4F, or something like that, which is a pattern that is easily identifiable by eye, but quite hard to write a parser for, in order to discourage people from programmatically filtering these out. So again, the 8 code points I've allocated in the current version of this draft follow a similar pattern to the TLS grease ones. The idea being that it should be easy to eyeball them, but it should discourage people from actually writing a handler to deal with them specially.
Should we, this draft also agrees, does it also agrees the version numbers? We have version numbers in SEIPD, key, and signature packets.
I don't remember. We can. I think so. I would need to double check whether it actually says that in the draft. I think it does, and I think it should. But I don't remember off the top of my head if I included that in the list. I think I included. I basically included all of the registries apart from packet types, which only go up to 63, and there was one other one. I can't remember. There are a couple of registries that are restricted in size, and those are treated specially in the draft. And I think everything else should just be blanket. They're allocated in every registry. And I even allocated them in registries where it makes no sense to even have a greasy code point, like in the S2K usage octet. Like, what does that mean? But it's reserved anyway, just so that it's consistent across the board. Again, this is the same. It's same in TLS. There's a couple of different registries, and they all have the same. Yeah, I think there's multiple registries in TLS that have the same code points allocated. Don't quote me. Maybe somebody from TLS can tell me otherwise. But
okay, so this seems like this is a kind of mechanism that's spread across multiple protocols and IETF working groups. So I guess at some point we'll ask the list. Are people okay with us doing this? Essentially, it's registering code points, describing how to use them. So okay. I don't see anybody else in the queue.
Okay.
Let's go to the next one.
Okay, so and this is the third of the this kind of small drafts that I'm talking about, and I'm calling this user attributes. It fixes a couple of issues, or maybe gets ahead of a couple of potential issues. Let me say. So in key servers in particular, we have an enormous spam problem, and a lot of energy has been expended trying to find ways to fix spam. So, for example, we have email-based authentication, and we have attested signatures, and so on. And attested signatures in particular have an issue because traditionally in key servers, if I make a certification revocation over somebody else's user ID, I can upload that to a key server. The key server will automatically attach it to that person's user ID and serve it with their certificates to everybody that looks for it. But a certification revocation signature is just like any signature over a user ID. It is open to abuse. If it's not filtered, if third parties can just upload signature packets on top of your certificate, they can flood it. So the attested certifications allows the key owner to determine the form of their certificate that is served to people by limiting the number of third-party certifications that are attached to that and served to third parties. The problem being that if I am issuing a revocation over somebody else's user ID, I'm essentially saying that they are fraudulent, or that they have made a mistake, or that I have made a mistake. They may not be willing to sign over this using attested certifications to allow it to be distributed. So while on one side we have this as a possibility for abuse, on the other hand, we have distribution of revocations is still important. So how do we square this? How do we balance out? The one suggestion is that we put these as embedded signatures into the subpacket area of some other signature. That's suboptimal for loads of reasons. First thing is like the unhashed area of signatures is a bit of a wild west anyway. The question of what is reliable in them is vague. What happens if you create a second, a superseding signature over the same object? You have to copy all of the unhashed subpackets into the new one in case they get deleted by the receiving client. Or maybe a receiving client just goes, I'm just going to throw away the entire unhashed area. I don't care. It's not a solid, reliable mechanism for distributing revocations. So what I'm proposing in this is that we specify an embedded signature attribute subpackage rather than an embedded signature subpacket. It's basically the same thing, but instead of going into a signature packet, it goes into a user attribute. Now, user attributes are kind of unloved. Really, the only use of them at the moment is to distribute pictures, and basically all of the key servers now strip them out. They're not really used for anything, but they are still in the grammar. They are still permitted, and they are extensible. They are a container for subpackets. There is only one subpacket type currently defined, but we can specify more if we wish. The advantage of using the attribute to store revocations is that I can attach an attribute to my own certificate containing a revocation that I make over somebody else. So it's my certificate revocation list attached to my certificate. And generally, I'm not, if I'm being a good signer, I'm not going to be revoking that many certificates over the lifetime of my key. I won't be flooding my own certificate via this method in a way that maybe somebody so a third party might want to flood mine, but that doesn't work this way because it's a user attribute subpacket. I have to certify over it myself with my own signature, and then it gets distributed through all of the existing mechanisms because it's already defined as part of the grammar. And again, as a bit of a drive-by, I'm also deprecating the image attribute subpacket because I don't think there is any justifiable use for it in the modern world. I think it is used mainly for abuse, and I think even the real use cases, which is to attach a picture of yourself to your own certificate, are questionable from all sorts of points of view, including privacy. So I think we should just draw a line under them. So again, this is the draft, this is the repo, and if anybody has any questions, please step up.
I don't see any. I think we're in kind of low energy mode this morning, so it's it happens.
That's fair enough.
So I don't see questions on this.
I have one question on this.
Sure.
How do you see? This goes back to my usual question about how do we test whether this is working or not. How would you modify? So this is all about sort of fitting into the existing grammar so things can be redistributed. Are there operations that you would want to do with your own certificate to use these new kinds of subpackets?
So the way that I would think of it is like we already have mechanisms to generate these revocation certifications, revocation signatures. So what I would suggest is that as part of that, instead of attaching the certification revocation to the subject certificate and then uploading that to a key server, which won't necessarily work. What you do is your local client would attach this to a user attribute packet, sign over it then with a normal certification signature, same as you would over any other attribute packet, and then you'd upload your own certificate by just the usual methods. I think the main change would be in the receiving implementation, because the receiving implementation, whenever it sees one of these things, should be able to recognize it, should be able to find the target certificate that it refers to, and then should take the revocation signature and attempt to apply it to the target certificate. And in that way, I can use my revocations and be reasonably confident that some third-party client somewhere will pick these up and do the right thing with them, essentially.
Okay, so I think I can see how to test the consumption of this, for example, with like a SOP verify user ID, because the root, the authority certs would contain the would contain their own revocation of a certification that they had issued. In that case, I don't think I see how you would generate these things, and so maybe that's worth sketching out as a merge request against SOP of like where, you know, how you would stuff this in the right place.
I think it wouldn't be that much different from the workflow for key replacement, because again, what you're doing with key replacement is you have two certificate objects and you're saying add a reference on one of them that refers to the other. In the case of key replacement, actually worse because you have to add them on both, you know, to refer to each other mutually, whereas this one is unidirectional. So you would only need one piece of secret key material, for example, rather than two for key replacement. So I think if we solve the issue for key replacement, I think it should be generalizable or adaptable to this. I think it would be a similar workflow in terms of what gets passed in and what gets passed out.
Yep.
Okay.
Onwards?
Onwards, indeed. So this is the big beast, semantic cleanup, and this is the one that kind of rears its ugly head anytime I have private discussions with people in OpenPGP. It's like, how do we fix the semantics? There's messes in many places. So historically, so if we think way back to the beginnings of PGP, before it was even OpenPGP, it was just RFC 1991 was essentially a description of the artifacts that PGP, the original software, produced. And it was essentially a description of the wire format and some notes about the semantics, which weren't comprehensive by modern standards. And as that has evolved through time, through the various RFCs, there are bits that have never been fully nailed down. So there are holes kind of everywhere in the stack, from even down as far as the wire format. In a couple of places, there are some wire formats that are specified but not actually fully described. The type 40 timestamping signatures, for example, are just like they're basically a hole in the document, because, you know, how people actually implemented them, it's not really clear. So we have all of these bits and pieces where if you actually wanted to sit down and write a full implementation from scratch referring just to the RFCs, there are bits that you cannot build, and you have to basically you have to do trial by error interoperability testing with other implementations, or use the tribal knowledge, as it's been called, which is basically the collective experience of the people in the working group, or the people who have been building these things for a long time. And that's unsatisfactory for many reasons. So we have all sorts of problems here. I won't go through them in excruciating detail, because as this is people have morning brains. I'm sure anybody who has been working in OpenPGP for any length of time has run into at least one of these at some point. So this document, which has become increasingly unwieldy, but I think is a good starting point for just listing all the things that need to be fixed or need to be clarified. And I have 2 slides here full of things. So there are 11 signature types with some kind of clarification required. Some usages are have unclear utility and probably should be deprecated. The signature target subpacket doesn't actually work as designed. It is currently possible to recursively embed signatures within signatures ad infinitum, which could break parsers and is silly, so probably should be explicitly forbidden. We need to clarify how to deal with conflicting subpackets, and also deal with which subpackets belong where. Something that I ran across just 2 days ago when working on Hockey Puck was there are several keys out there that have exportable certification subpackets in their subkey binding signatures, which makes absolutely no sense, but they exist. They're out there in the wild. Some implementation at some point thought it was a good idea to create them. So I think we need to specify better what subpackets are actually used for and what they're not used for. And also, we have key flags which are kind of vague, because some key flags say, well, this can make signatures. What kind of signatures? Which specific signatures can it make? So by categorizing the signature types into broader buckets, we can say a particular key flag refers to these particular signatures, a particular key flag refers to these other ones. As I mentioned earlier, this also constrains the method grammar. This could be broken out into a separate document because it's very loosely coupled to the rest of the document, and so on and so on. I'll stop here. The document itself is quite long, but I believe it is divided up into digestible sections that can be read, one at a time without too much cross-referencing. So this draft would also be. It might also be possible to split this up into multiple drafts, maybe if we want to tackle them in smaller chunks. So I'm going to leave it up to the working group if they want to tackle all of this or some of this, if they think it should be split up into separate documents, or if we should keep this as a general document to keep track of progress over time. I'll leave that up to everybody else to decide. It is quite large, but I think it is necessary, unfortunately. So it is here. If you want to have a look at it, and if you have any questions, this is my last slide.
Okay, low energy mode continues.
Yep.
This kind of strikes me as the kind of thing that would be an interim meeting all by itself.
It is substantial, yes.
Yeah. As a question, is it if you were in the draft, is it recommending changes that would affect implementations in parts as well as just kind of clarifying text?
There are quite a few places where implementations do not currently agree. And so any clarification would naturally mean that at least some of those implementations would have to change, yes.
Okay.
One thing that I did want to do this is make sure that this did not specify any new formats. It just clarified things that were already in the existing RFCs. Now, I did mention the timestamping signatures, which are so vaguely specified at the moment. It might actually count as new wire formats to even specify them at this point. And fair enough. If we want to pull those out of the draft and treat them at a later date, that I'd be happy with that as well. But the scope of this is generally, these are the things that are already mentioned in an RFC somewhere already, but are not satisfactory in some way or other.
Okay, so I'll ask a stupid question. Why wouldn't you just update RFC 9580 to make these 53 pages of changes?
That's also possible, yes. But however, I suppose we've only just got RFC 9580 out the door, and if we open an RFC 9580 BIS document now,
we were constrained in what we could do for RFC 9580, right? We were chartered specifically to update the cryptographic primitives. And we snuck a few small cleanup changes in there, but the kind of changes you're talking about here would not have been within our charter to do for 9580.
So, but maybe Andrew's reaction actually gives us a hint. Perhaps this is something to consider, but to let it sit for a while.
I think the document as it currently stands. Well, as it currently stands, it's actually 1.5 different documents because I stole some of DKG's revocations document to try and redivide the work across different documents. And so there's section 8 in particular is written very differently from the rest of the document because that actually comes from a different document. I think this document is useful as it stands as a way to keep track of things. Whether this document will ever become an actual RFC in its current form, I don't know. Maybe it would be better to fold bits of it into an RFC 9580 BIS instead. I think that's really up to the working group and how the working group thinks we should proceed. But I'm keeping this document essentially as a to-do list, effectively, and well, it's not just a to-do list; it's a to-do list plus suggested fixes, which again, in some places I feel quite strongly about, and in some places I'm quite flexible about. So it's. I don't believe that this should be published as it's not as a standards track document in its current form. No, but I definitely think that it would be useful if the working group could engage with it or sections of it.
Has anyone read the document? I haven't. I admit. DKG has. Anyone else? Daniel has as well. Good. So, in any case, I guess that at least the first thing would be to get some more eyeballs on what's in this document to try and get ideas as to how to process it, because there's a few different ways you could do it. None of them seem easy. So
I know Heiko is quite keen to get his teeth into it, because when he was implementing things in RPGP, he came up with a lot of the same frustrations that I came up with, and so I think he was quite keen to see something along these lines happen.
Daniel's in queue.
Yeah, I just wanted to say I personally kind of like that we're at the moment sort of making discrete sized improvements to OpenPGP by having a couple of small drafts that add a concrete new thing or clarify something, as opposed to opening up 9580 BIS immediately and kind of opening the door to anything and everything, right? But I could imagine that maybe once a bunch of these drafts have been adopted and maybe even published, we might consider again doing a BIS also to kind of merge everything back into the OpenPGP document, as has happened with ECC before and so on, right? So maybe that could be also a path to eventually merge this stuff into 9580.
I would say on that, if anybody wants to grab a section of this and take it away and work on it, please do. It is probably unwieldy in its current size, and dividing it up into manageable chunks may well be the best path forward.
Okay, so I mean, I guess another possibility, which I'm not quite sure if you actually offer this as an option, Andrew, is, you know, the working group could adopt a draft like this as a kind of a workbook for stuff we want to have written down for whenever in the future sometime somebody might update 9580. I'm not saying it's a good idea. I'm just saying, you know, it's a possible thing.
It's a possible thing, yes. Like, could we adopt it as a, yeah, as kind of like here's a miscellaneous stuff draft, and then eventually polish bits of it into publishable form? Yeah, possibly, yeah.
Okay. I guess we're not deciding today, anyway.
No, absolutely not. I'm just trying to give people a feel, basically, for what is in it and how almost how big the task is. Like if I go back to some of the previous bullet points, there's a lot of them, and those aren't even. That's not even a comprehensive list of bullet points. I think there's a lot of stuff in OpenPGP as it currently stands that is underspecified, and we do need to take this seriously as a problem.
Okay. So, okay, I guess again, thanks for doing all the work to document the infelicities of history. So, and I guess the action on this one is probably to kind of get people to read it and think about how to go forward.
Yes, please. Yeah, please read. It's absolutely not in any fit option as it stands, but please try and read bits of it. Just, and if you have any kind of viewpoint on them, please let me know. Speak up. Stick an email in the working group, and we'll go from there.
Great.
Thanks.
Okay. Thank you. We back to the chair slides, or?
Yeah, I think that's where that was the last slide that we had there. So we are a little early for the end of the meeting, but if folks don't have other business to raise, we can also just give you back the extra 20 minutes.
Okay, so I guess on a bunch of these things, there's a couple of chair actions that we should kind of poke the list about some of these proposals. Probably makes sense to do them one at a time, or rather than have provide a big Chinese menu to people and say, which do you want?
Sure. So we could raise specific drafts, like a draft a week or something like that.
A draft a week, yeah, sure. That'll get us to the holidays. Okay, but anyway, so the chairs will chat about how and when to poke the list to see of the various topics people claim to want to work on. Can we establish if the working group does want to work on them? So some will be a call for adoption, others, like the last item, will be more nebulous. So you'll see some email from the chairs on those things upcoming. And I think with that, is there any other business is the next question.
Not hearing anybody raise it.
So thanks to Scott and Alexander for taking notes. Much appreciated. And I guess we can go and hunt for coffee or take whatever remote people want to do. I think we're done, yeah?
Thank you all.
Thank you.
Thank you.
Yeah, thanks very much. Bye, everybody.